Hi, I'm Marc with Western Digital's Enterprise Hard Drive product team. Today we're going to talk about how you can unlock ultra-dense storage at the right price and performance with WD Ultrastar hard drives and VDURA System 12 operating system. So most of you probably didn't come to Supercompute 25 looking for information on hard disk drives. Might not have been on the top of your list for product discovery. But what we'd like to talk about today is if you haven't heard about hard drives lately, there is a lot of technology innovation moving to ever higher capacity points that are really the right space for your warm data workloads. That's what we're going to talk about today. So before we get into AI and HPC specific workloads and how that's impacting your storage tiers, let's take a look at just in general at the data center storage tiers today that are in place. And when you look at it, the top hot tier for instant access and processing, for online transaction processing, for mission critical or line of business critical information. At the top, that's really about 10 to 15% of all data storage in today's workloads are on hot SSD flash architectures. Now, when you move down into the warm workloads for everything from application data to files to media and backup, especially, all of that is really associated with a warm workload. That's up to about 75% or even slightly higher of all data under storage. So all the data that's consumed and created is stored on the warm tier on hard disk drives in the data center. And then cold, we won't forget about cold storage, really for archival or the backup of the backup. That's about 10% or so of the data. And when you look at these workloads on a performance basis, of course, flash and SSD is what everyone is talking about for accelerated AI workloads. And it really is the only level of performance in the data center that's suitable to run any function. So you can store any workload and process and use that on performance of SSDs in the data center. But just because you can store your data on SSDs, it doesn't mean that you should. That performance comes at a price, and that price can be up to a 6 times multiple. So we're not saying that HDDs should encroach and perform at that work level. That's not going to happen. You're still going to have flash SSDs as part of your tiered storage mix and your hybrid storage systems. But if you take one thing away from this talk today, it should really be that as a customer and a data system operator, you should really know your workloads, understand which tiers of storage offer the right performance, and then look to match that to the storage media with the right price performance ratio. And that's where your blended hybrid tier system with a mix of SSD and HDD comes into play. Now let's take a look about how AI is really impacting that and changing those storage tiers. So of course, AI is generating massive amounts of content and information. It's also consuming and ingesting massive amounts of content. And most of that, while it's being processed on the hot storage tier, most of that is being stored in the data lakes as well. The storage tiers are evolving, so the hot tier is growing faster than any other tier as well. So when you're looking at your mix and your allocations, you should probably over provision on hot tier as well. And also another major impact is that AI is using AI. So AI storage systems are really starting to understand and recommend which data tiers your data should be residing on for the best workloads. And when we look at hard disk drives for the warm data tier, HDDs are really what we would call the backbone. It's certainly in terms of volume, it's the main storage media in terms of space. Why is that? It's because it does have the right level of performance. It can perform any storage operation in the warm workload tier at the right price point. And what we'd see again is that flash media and SSD storage can be up to about 6x times CapEx or acquisition cost to be in that flash tier as well. So HDD provides the right mix of price and performance, and that's why it really is the mainstay and what your systems are built on, the foundation for your capacity storage. Now let's talk a little bit about performance of HDD, because when we at Western Digital, we like to think of hard disk drives as high performance storage. Most of you, if you were to ask, is HD a high performance storage media, you'd say no. That's all flash, SSD, or DRAM. That's what the performance is all about. But for the right workload in that warm data tier, HDDs really are high performance enough to perform any storage operation. So now let's look at some of the details. So with our enterprise hard disk drives in the industry, you'll see read and write speeds into the mid to high 200 megabits per second, megabytes per second. And that's, again, enough throughput to really manage most of the data that might be residing into the data lake and then flowing into your AI ingest and learning systems as well. HDDs are reliable, proven technology. Again, they've been around for years, yes. The technology has been changing and evolving really rapidly. We're going to talk about that upcoming in just a moment. And HDDs are scalable and hitting these high capacity points. Really impressive. We'll talk more about this, but up to 26 terabytes in conventional recording and up to 32 terabyte in shingled magnetic recording. Now, if I were to ask you about performance, again, most of you would think flash, SSD. So let me ask you a question. If you were asked, like, who is the fastest, most efficient runner, you would probably think of an Olympic sprinter, right? And that might be what you would think of as a performance runner. But and that is true for the workload of 100, 200, 400 meter sprints. But let's take a look at it through a little different lens. Is a marathon runner a high performance runner? Absolutely. For the workload of a long distance, a marathon workload, that marathon runner is absolutely high performance. So both things can be true at the same time. So you'll see SSDs are definitely in the hot performance tier that is needed to process AI and HPC workloads, but so are HDDs. It's just doing a different job and a different function. Let's look at technology for HDDs. HDDs have been in the market for many decades, but the technology has really been evolving and rapidly changing. At Western Digital, we constantly are innovating and creating new technologies, especially with our new shingled magnetic recording drives, the SMR products that go up to 32 terabytes. We call it Ultra SMR, a combination of some unique firmware and hardware that are really hitting its stride. So we're able to hit higher capacity points, up to 15% higher than conventional magnetic recording with SMR. And now with VDURA, with their System 12, having native host support and certain write algorithms involved, it doesn't take really complex or costly engineering to be able to bring up a shingled magnetic recording hard drive. So the general market, using VDURA systems, can take advantage of a Western Digital Ultrastar hard disk drive with SMR to have the highest capacity points and really be in that optimized TCO range. With Western Digital, we've made several advancements on mechanical innovation and different recording technologies, and also we do have some flash that's used inside our enterprise hard disk drives called OptiNAND. It's used for several different functions. It's not to store data on or customer data on, but it's used to help increase our tracks per inch and really increase the capacity of the drives. At WD, we've been innovating technologies, and really what you'll see today, many of our technologies like ePMR, OptiNAND, and Ultra SMR are really serving the market now to deliver a product that's high capacity with advanced technology today. In the future, we're investing heavily into HAMR technologies that will, again, extend the capacity points up. Now let's watch a quick video on WD's Ultrastar and Ultra SMR technology.
Scale storage. Storing data has traditionally been done.
If you can hear it.
Putting one bit directly in front of the other. Until now. Get out of line and get ahead of the competition with Ultra SMR by Western Digital. Conventional magnetic recording, or CMR, uses discrete data tracks separated by a small gap to ensure random writability, but at the cost of space efficiency. With modern SMR from Western Digital, we overlap these data tracks, eliminating the need for gaps while encoding data. And now, Ultra SMR goes one step beyond, incorporating distributed sector encoding, which spreads a small group of sectors across a wider area for more robust data protection. And soft-decoded track error checking and correction, which adds additional parity bits that improve on previous hard-decoded ECC technologies by allowing multiple sectors to be corrected. Each sector that you correct makes it easier to correct others, just like putting together a puzzle. The result is greater data integrity, greater disk durability, and up to 18% increase in capacity. If you're already using SMR, Ultra SMR is fully compatible, slotting seamlessly into your existing infrastructure. Whether you're storing massive amounts of user-generated content, accessing historic financial data, or processing the latest data, Ultra SMR provides the most reliable data protection and highest storage capacity on the market today. Get out of luck. Get Ultra SMR, durability for your data. Western Digital, the foundation of innovation.
So I'm not sure if you can hear that at all. It is up on YouTube, so you can, at your own time, play that back, please. But we were really talking about the architecture of our SMR drives. And when you look at it, so these are our two products side by side. The CMR drive up to 26 terabyte, the SMR drive up to 32 terabyte. If you peeled the label off of the front, the drives would be identical. All the hardware, the componentries, the media, the heads, they're all identical between those two products. So what's different with the SMR product? It's really the firmware and the way that it processes and the way that the drive formats and lays out the tracks. So in the conventional magnetic recording drive, the tracks are parallel, discrete, and not interconnected at all. On the SMR drive, they're shingled, they overlap. You think of it like roof tiles, like slightly overlapping and touching. But the idea, again, is that you can fit and wedge more information in. Rather than laying out the bits sequentially, they can be slightly offset for in how they're laid out. And the way that we're able to do this, it yields capacities that are up to 15% higher over conventional magnetic recording. So you're in a much better value and really being able to reach that most ultra dense spot. Now, in the past, working with SMR, it was complicated. So the writes to the drives, especially random writes, it's difficult for the drives and the file systems to be able to process and utilize that full capacity of SMR. So that's all changed over the last years, and especially with companies like VDURA now coming out with their System 12 products and software. So System 12 includes some native support for SMR. So that just means that any customer can take advantage of the capacity and the value of SMR storage capacities using VDURA System 12 without having to do custom application layer changes, without having to rewrite your file systems and go through years of engineering efforts to continue to fine tune it. Now, it's not perfectly tuned for your application, but it's a long way there straight out of the box. So that's a huge advantage, and we'd like to thank our partners, VDURA, for bringing out this really exciting technology to the market to help bring the value to our customers together. Now on Ultrastar, I'll just give you a quick wind down and an overview of our products. We're focused on the high capacity products, but the Ultrastar range does start at 2 terabytes and goes up every 2 terabyte increments all the way up to today 26 terabytes in conventional magnetic recording. And then on our SMR drives up to 32 terabytes today. They have similar reliability specs. Again, as I talked about, under the covers, it's the same hardware. the same motors, the same heads. So it makes sense that the drives have similar reliability and similar performance capabilities as well. So with SMR, it will scale up to 32 terabytes. Now, what's next? What's next generation? I won't go into any of the details here, and without being under NDA, but we will give a little bit of a teaser. I talked about how at each generation, each new version of the product models that come out, which is typically on about a 2 or so year cadence, you'll see an uplift of up to about 15%. So where our drives are on SMR at about 32 terabytes today, CMR about 26 terabytes today, you can look at about a 15% uplift. And this all has to do with increased efficiencies, locating the track spacing even tighter than it is today. And so you can do the math on the next generation, on the kind of ranges that we should be. And that's coming out relatively soon. I won't give any specific dates as well, but check back with us, often. And then on the Hammer products, again, those are under development, but with the high capacity points that we're going to hit with CMR and SMR, that should really bridge our customers over on proven and known technology until Hammer is really prime time and ready to go. So that's the WD Ultrastar product range, and now being able to take advantage of SMR on VDURA System 12. So thank you to the VDURA team again. Any questions from the audience? All right, well, thank you all for attending, and if you'd like to see the products, this is a cutaway of our 11-disc technology as well, so you can come up and take a look and hold it and see the 11-disc platters that are built into the product here. So again, a lot of high technology in the products. Thanks, everybody.